So for planning a study, there's two big breaks in between Unit 3. We are going to spend the first half talking about observational studies, so this week, and the next week we're going to talk about experimental design. Just to kind of hit some key terms that you'll see on the AP exam, you'll see it in your math lab because they're going to ask you questions about these types of things. You have your population, which is the entire group we want information on. Info about. A lot of the time you'll also hear population referred to as population of interest. And so if you are interested in a specific group, you have to make sure you are pulling data from that group. You can't just take the most convenient data that is accessible to you. If I want to talk about all high school students, I need to be sampling from all high school students in the general area that I want to. If I only sample from RHS, I can only talk about RHS students. If I want to talk about Richardson ISD, I need to be sampling from all 4 high schools in order to draw conclusions about that. Now, realistically, if I go out into the world and I want to get information, in a perfect setting, we could go in and we could collect a census, which is data from every individual in the population. Now, we've talked about how taking a census isn't always going to be your best option because a lot of the time you're not going to get information from every single person. So instead, what we do is we go in and we take a sample. So this is going to be a part of the population we actually examine. And a lot of the time, whenever you're going in and you're taking your sample, you want to make sure that you're doing it with a random element. Either you picked all of the people randomly through a random number generator, or you pulled names out of a hat, something where you have not chosen the people that you want to participate. Like you didn't manually in your brain select someone. One other term that I'm going to kind of add on here because you do see it. If you see parameter of interest, that is basically going to be what you want to know. So if today I'm going to use the example of opinions on the RHS cafeteria food. That would be my parameter of interest. My population of interest will be RHS students. So a lot of the time in these FRQs, one of the first questions they ask you is, what's your population of interest? What's your parameter of interest? What is your sample? Your sample is always going to be, what did you actually collect? So what data do you actually have to talk about? Now, one thing about the population that sometimes is helpful is if you are able to have a sampling frame. Basically, all that is a list of everyone in the population. If I wanted to break that down, again, just kind of using my example of cafeteria food, if my population of interest is RHS students, my sampling frame could be a roster list of all student ID numbers. And then I could go in and use some sort of random process, either picking the numbers out of a hat, using a random number generator, and I can select 100 people from all RHS students. So parameter of interest, population of interest, sampling frame isn't necessarily something you have to use terminology-wise, but if they ask you what is the sampling frame for a particular question, you're just saying it's the list of everyone. So potentially like a phone book or a list of every ID number, but something where all of the data from your population is collected. Okay, now to kind of talk about the 2 breaks in this unit. I know it seems crazy, but it's only 4 lessons. So for observational study, we are going to cover these in 3.1 and 3.2. And for experiments, We are going to cover this in 3.3 and 3.4. I will say this. A lot of what we're going to have between the two things, between observational studies and experiments, are going to sound the same. Bless you. The methods that we use to pick our random samples are going to sound similar. The process is going to sound similar, but the difference is going to be that you potentially have different names. So when we're doing it in an observational study, it's named differently than what it is in an experiment. So one thing about observational studies, the big idea behind that is you are not going to impose any treatments. You are simply there as an observer. You may do things like give them a puzzle, give them a test, a quiz, something, but you are not purposefully altering their life in any way, shape, or form. There's two types of observational studies you could have. You could go back and you could look at data that has already been collected. That's retrospective. So potentially going back and looking at medical records. Maybe you are examining how, having taken pre-K3, how many AP classes you take in high school. You can go back and look at how many AP classes people are in right now and compare it to, were they in preschool or did they start in kindergarten, first grade? Also, you have your prospective, which basically means you're going to follow your sample into the future collecting data. And that may be something where you have certain checkpoints where you're looking at growth. A lot of the time with babies, they have prospective studies where they try to see all of these different things that happen to babies as they are developing. Does it affect them later in life? So did they get formula? Were they breastfed? Did they sleep on their own? Did they sleep with their parent? Like all of those things they try to see, does it have an effect later on? So they'll follow those babies as they grow up. So that would be something where you're following them into the future. The big idea that we focus on in stats is going in and taking sample surveys. So what we're going to discuss today are the different types of sample surveys you could have, and we're going to talk about the different types of bias you introduce by doing a sample survey. So it's basically an observational study where you're just trying to learn about the population. Now, experiments, we will not talk a ton about today. Basically, the big idea here is that you are going to be imposing some treatment. They're listening to music while they take a test. They're not listening to music while they take a test. They are going to drink coffee before they drive. They're going to drink coffee after they drive. Things like that, where you are altering their environment in some way to see if there is a response. The big idea for experiments is you want to have a well-designed experiment where you're able to determine cause and effect. The one takeaway from that is if you are doing a observational study, the one idea that gets hit a lot on the AP exam, observational studies cannot determine cause and effect. I can see that there is potentially a relationship between two things, but I can't necessarily say that one is causing the other. The reason being is in observational studies, you are not altering their normal day-to-day life. So if I want to see, does an exercise class help you lose weight? If I'm doing an observational study, I don't know, did that person change their diet? Did that person also start walking more? Or did they start riding their bike? Or did they stop eating fast food? You can't necessarily tell that person in an observational study they can't do things or they should be doing things. That would turn it into an experiment. So from just observing alone, you can never, ever, ever say that X is causing Y. You can say that there is this relationship that we're seeing, but you don't know what else is going on. Yes, they could potentially answer questions and tell you like, no, I don't work out more or things like that, but you don't have control of that environment, so you can't say this is specifically a result of this changing. Now, the other thing that I mentioned a little bit earlier was the fact that a sample is only generalized to the population from which it was selected. Basically, if I want to talk about all high school students in the United States, I need to be sampling from all high school students in the United States. If I only sample from Richardson High School and only sample my AP Stats students, I can only say these results are valid for my AP Stats students at Richardson High School. So don't expand your population of interest if you're not technically sampling from them. So they will ask you questions of, we went to a teacher conference and we asked all of these teachers at this conference what they think about math. And they'll say, what is my population of interest I can generalize these results to? You really can only say it's applicable to those teachers at that conference. So if you want to say something bigger, you need to be sampling bigger. So anytime you see questions like that, it can only apply to those from which you sample. Okay, now here's where I filled in some of the blanks for you so that you didn't have to do a ton of writing today. In sampling, we want things to be represented well. We want the population to be 100% represented in terms of all of the different groups that we have. There are good methods and there are bad methods. The first thing we're going to talk about are the bad ones. So in the case of issuing a sample survey, so going out, giving someone a questionnaire, having them answer it, you want to be able to select randomly from the population because, again, ideally, census is not going to work. So what we do is there's two options that happen quite frequently, but they are not good methods for data collection because they're not representative of the population. First one, convenience sample. I'm going to use a general question prompt, and I'm going to try to apply it in all of these settings. If I want to know what do RHS students think about the cafeteria food, I can take a convenience sample. I could stand outside of the cafeteria at a lunch, and I could survey the first 100 students that walk in the door. That would be a convenience sample. Now, yes, I get 100 students. I get my sample made. However, that is going to leave out a lot of different groups. So one, I'm only sampling A lunch students. Maybe they get the freshest food and they're like, yeah, I think it's fine. It's not bad. Two, I'm only sampling at the cafeteria. I'm not getting students who bring their own lunch and eat in a teacher's room, or bring their own lunch and eat in the courtyard, or that they eat in the eagle's nest. I'm only getting one group of students, and it's those that are going into the cafeteria. So by doing that, I'm not representing everyone. So convenience samples are usually very easy to do. They save you a lot of time, a lot of money, but they're generally not going to be representative of everyone in your population. So not great. The other bad one is a voluntary response sample. Basically, I post a link in the cafeteria on Eagle Eye, somewhere Eagle Ear, and it's a survey. If you want to complete it and share your opinion about what you think of the cafeteria food, you can. And for the most part, most of you probably will be like, yeah, I don't care enough to do that. So you're not going to actually answer the survey. Even if you happen to love the cafeteria food, you're probably not going to take the time out of your day to go answer that survey. The people who are going to take the time out of their day to answer a survey generally are the people with very, very strong opinions. And a lot of the time, it's people with strong negative opinions. If you ever go on to Yelp or to Google reviews, most of the time you're going to find bad reviews and not good ones, just because a lot of people, when they are upset, they want people to know they are upset. So that's when they choose to share their opinion. So if I did that survey in that way, where I just posted a link somewhere, probably most of my responses are going to be, the cafeteria food sucks, and that's all I'm going to get. So with that, yes, you may be getting a wider, different demographic of students, but you're not getting a representative group. A lot of the time, people don't take the time out of their day to go write a positive review on a restaurant's website or something like that. So generally, again, not representative. So when these samples are not representative, they're not great. On the far column, I just have different examples of how they could be used in other settings, but I'm going to try to use my same general prompt across the board. So for the next groups, we have our simple random sample, which is also called an SRS, stratified, and cluster. We have our favorite child, and that is the SRS. Basically, it is a general, everybody's in one big pot, you're mixing the pot, you pick people out randomly. The definition, which comes up more often than you would think, is every combination of, if I'm trying to sample 100 kids, every combination of 100 students has an equal chance of occurring. Basically, 100% randomness. The two common methods that we use to describe an SRS, we have our hat method, and we will go through the process of describing these in the next lesson. Hat method, everybody's name gets written on a piece of paper. We put the pieces of paper in a hat. We mix up the hat. We draw randomly. That is true randomness. The other thing that you could potentially use is a random number generator. So your calculator, while it is random, it's not really random because if you all reset it, we all get the same random numbers because it's a computer. With a random number generator, you could have random numbers be produced. You could tie those numbers to certain people, and those people become your sample. So simple random sample is just, in general, complete randomness. Everyone's in one big pool. We're picking from that big pool. The kind of subset of that, it's almost like a multi-level sampling, but stratified and cluster both implement some form of SRS in how they do their sample. I will make a little note here just because I like to point it out before I start discussing them. You want to make sure you know the difference between these two. And they're going to sound similar because we are going to be grouping people together. And so people get them mixed up quite often. So the difference, stratified random sampling is going to group people based on a similar criteria. So if I think the lunch period you have has an effect on what you think of the cafeteria food. Like I think A lunch people probably like it more because it's fresher versus C lunch where it's busier, the food's kind of been sitting out a little bit. So what I can do is I can divide you into groups. I can divide you into students who have A lunch, students who have B lunch, and students who have C lunch. And what I can do with a stratified random sample is I can take a couple of people from each group. So this is just taking a few of those people, combining them together, making your big sample. Now, with the simple random sample, if it's true randomness, you technically could pick all people from one group. Like if I sampled from the entire student body and I sampled 100 kids, I could get 100 people who have A lunch just from randomness alone. So this method is kind of guaranteeing if I think some other variable is affecting my results, it's going to guarantee that I'm getting representative people from each group. So stratified is taking a couple of people from all of the groups, basically going in doing SRSs within each strata. Now, for the cluster sample, typically what this does, and it kind of sounds similar, but I like to think of cluster as more location-based. And a lot of the time, these clusters are, when you start to pick them out, you want them to be location-based, but you want those locations to kind of be representative. If I only did clusters based on like lunch periods, fourth period, then I know I'm going to get certain people who have A, B, C. But I kind of want a mix of everyone. So what I may do if I'm trying to figure out what do people think of cafeteria food, maybe I pick advisory classes instead. Advisory classes are all mixed. They're all different types of students in one classroom. Yes, your grade level is the same, but you have students who are in advanced classes, students who are in on-level classes. You have high income, low income. You have people who bring their own lunch, people who eat cafeteria food. Like, you have a mix of people in those advisory classes. So what I do, pick 5 advisory classes. I go in, and the thing about cluster is every member of the cluster becomes your sample. So in stratified, you're picking a couple of people from each group. So like 5 from A lunch, or 30 from A lunch, 30 from B lunch, 30 from C lunch. In cluster, if I pick 5 advisories, every single student in that advisory class is a part of my sample. So it's kind of like taking a census of the groups you select. So not a big census in terms of the whole population, but a census of your cluster. A lot of the time you'll find in actual sampling, especially when it becomes like presidential season and all of that, they do a lot of cluster sampling because it makes sense for them to go in and ask one zip code who they think is going to win the presidential election versus I've selected 1,000 people all over the country. Maybe I pick a zip code in the South, a zip code in the Northeast, a zip code in the West, and everyone in that zip code becomes a part of my sample. So it keeps you in one location and able to collect your data a little bit quicker versus being all over the place. So know the difference between these two. I can guarantee you they will give you multiple choice questions that describe how they're going to collect their sample, and you have to pick, is it simple? Is it stratified? Is it cluster? Is it voluntary? And they will always have these 2 answer choices together, meaning they're not going to just be like, oh, we're not going to put cluster on there so they get it right. They're always both there. So you have to know the difference between the 2. The last one for a good sampling method, the last sampling method, is a systematic random sampling. Basically, you're going in and you're starting at some random point and you're picking every 5th person. Usually you roll a die, use a random number generator, you pick a random number and that's your starting point, and then you pick another random number and every whatever number person is a part of your sample. If everyone's in a big line and I just want to take a sample of all of these people at the polls, but I want to do it randomly, I can use a systematic random sample to pick every 5th person and they become a part of my sample. So any numbering system is systematic. Okay, now most of what we do in our collection of a sample is going to be done without replacement. You generally, for the most part, do not want to have the same person complete your survey twice. And so because of that, replacement, there we go. Because of that, you take them out of the sample entirely. When we go in and we actually write these things out, you will have to say, we are not replacing this name. I am picking a person from the hat, taking their name out of the hat and throwing it away. So they make it like when you write these responses, it needs to be foolproof. Like think back to like kindergarten, 1st grade, where you had to learn how to write instructions. And they have all those videos of the teachers who like ask their kids to tell them how to make a peanut butter and jelly sandwich. And they're like, take out the bread, put peanut butter on it. And the teachers are like putting peanut butter on the loaf of bread, like the wrapping in the plastic. It's like that. It needs to be like completely descriptive. They can't just assume, hey, I picked the name out, I'm not going to use it again. You have to tell them you are not using it again. So when we actually write these out, I'll model that for you, but it has to be like dummy proof. Like they could pick up your paper and they can do exactly what you say step by step. Everything, as much detail as you possibly can give them. Okay. The last kind of thing we're going to talk about is our sources of bias. There are a couple of things we discuss. If you are sampling and your group is not representative of the desired population, you are introducing some form of bias into your sample. One that we've already discussed, and I know this is a type of sampling method. They sometimes refer to it as the method itself. Sometimes they refer to it as a source of bias. But if you are doing voluntary response, you are introducing people with strong opinions. You are not getting a representative group for your sample. The other thing that we've already discussed is undercoverage. I mentioned the fact that I may stand outside of a lunch and sample the first 100 students. If I do that, I'm not getting students who have B lunch, I'm not getting students who have C lunch or eat in the Eagle's Nest or eat in their teacher's room or in the courtyard. I don't have those groups represented, so I have undercoverage of the population. So anytime a group is not included, you have undercoverage. So if I'm going to go in and mail a survey to all of these houses to see what they think about speed bumps in the neighborhood. I get everyone who has a house, but maybe I didn't mail them to the people who live in apartments. So that group would be underrepresented because I didn't pull apartment addresses. I only pulled house addresses. So that would be undercoverage. Now for the thing that I'm going to, non-response, let me write it out before I talk. I'm going to kind of draw a connection to these two things. And only because these are commonly mixed up, just like our cluster and our stratified. So I am going to highlight the fact that you should know the difference. Voluntary response, and I'm going to add a little note here. No sample is selected. And I know it says it in the words, but sometimes you guys read your handwriting more than you read my typed text. With voluntary response, you put your link out there. Whoever responds, responds. You didn't send it to anybody specifically. You didn't pick anybody randomly. It's just out there. Whenever you're doing non-response, you selected a sample. You did what you were supposed to do. You randomly chose 100 RHS students to send your survey to. You got their emails. You emailed them the link. And then they only responded with like 20 of them. So if you do what you're supposed to do and they still choose not to respond, that is a non-response bias. It's not that you did an incorrect sampling method by using voluntary response. It's just you didn't get results, and that's okay. You can go in, you can do it again. You can send it to a new sample of 100 people and try to get responses that way, but I can guarantee you they will have questions where, like with cluster and stratified, both of these answer choices are there. And you just need to focus on, did I select a sample? If I did, it's non-response. Or did I not select a sample and I just had it out there for my population to see? If that is the case, it is voluntary response. So non-response is you picked them and they didn't reply. Voluntary is you didn't pick them and the people with strong opinions did reply. So that is one that gets mixed up quite often, just like stratified and cluster. Now, the last type of bias, this is going to kind of be, and I'm going to do some more line drawing. This is going to go in, all of the things that go into the next page are all kind of blanketed under this idea of response bias. So anytime you ask a question and the person doesn't answer truthfully, or they don't answer with what they really think, that is a form of response bias. And there's a couple of things that can kind of fall into that category. The first thing is, it's just untruthful answers. A lot of the time, if someone's asking the question and you don't want to get in trouble, or you don't want to be judged, or you don't want them to tell your parents, you give them an untruthful answer. Basically, you lie. So one of the examples is, how often do you drink alcohol? If your principal is asking you that, You're probably going to tell them no because you should be telling them no. But you may potentially be lying just because you don't want to get in trouble for doing something you're not supposed to be doing. That would be a form of response bias. You answer, or they answer in a different way than what is the actual truth. Another form of response bias is going to be people will give silly answers. Basically, if they don't know what's going on, they just want to say something. A lot of the time, people just want their opinion to be heard. So if I ask them, what do you think about the STAR test or something like that, and they don't really know or have any opinion, they may just say something just to say something because they're being asked a question. Another thing could be lack of memory. It's not always the intention of them to lie or to give you an untruthful answer, but it's another thing where if you ask somebody a question, they're probably going to answer it, whether they think it's right or wrong. So if I asked you, like, what was your grade in Algebra 2? You may be like, oh, I think I made an A, and then maybe you made a B. So it could just be a lack of memory. Another big, or the next big ones, you could get different answers based on timing. Phrasing. If I asked you what your favorite sport was, and I asked you in February, or favorite sport to watch on TV, and I ask you in January, February, most likely a lot of people will probably say football because that's right around when playoffs start happening and the Super Bowl. If I ask the same question in June, maybe people say basketball because that's when the basketball finals happen, I think. I'm pretty sure. So the timing of the question can also change the answer. So that is a form of response bias. Now, another thing, and this is the big one that they usually include on the AP exam, poor wording. If you write a question in a way that is going to lead to a certain answer, you have a form of bias. So in the case of talking about line item vetoes for the president, if you specify specifically like what you think is going to, like specifically what item you want them to have the veto for, in this case, a lot more people said yes because it was specific to one thing. But if you have a more broad question of like, should they have it at all? Because you want people to disagree with it, that is when less people said yes. So you're writing the questions in a way that are getting responses that you want. It needs to be neutral. It needs to be just a question where you're not leading people one way or the other. So in this case, poor wording, phrasing is a form of response bias. All of these things, for the most part, they don't include them like poor wording bias, timing bias, untruthful answer bias. They'll just say response bias. So your answer choices typically are like voluntary response, non-response, response bias. And then you pick response bias if it's something where they are not answering truthfully for a certain reason. Okay, now the last thing we're going to discuss, this is a big vocab day. This is the last vocabulary, I promise. When drawing a sample, there's two types of errors that could occur. There's a good one, there's a bad one, as there is today in all things we do. The bad one first, non-sampling error. Sample data, incorrectly collected, recorded, or analyzed. Usually when the sample is collected in a non-random fashion. Basically, you made the mistake. You went out, you did a convenient sample, your sample wasn't representative, your data is incorrect, you recorded it incorrectly or something, but something in the process of collecting the sample data was wrong. That is a non-sampling error. Nothing you could have done with that data is actually going to be accurate to the population. Now, in the other form of error, this is not a bad one. Sampling error is basically going in and seeing that a sample doesn't always equal to what the population is. So realistically, if I were truly doing a sample survey for opinions on cafeteria food, I can't just take one sample. I can't just ask one sample of 100 kids and expect that to give me a true proportion of the school's opinion. I would probably do it multiple times, again and again, with different samples and see, okay, well, most of my samples ended up with people feeling positive about the cafeteria food, so I can say they think the cafeteria food is fine. You cannot really base your results on one sample only. In the span of our class, because realistically you don't have time to do samples and samples and samples and samples, we do only talk about it as if you're doing it once. But the idea is your samples can look different. I can take one sample from this class of 5 students, and that can be completely different than another sample from this exact same class of a different 5 students. So because there is differences in samples related to the population, that's just saying that those numbers can be slightly off. So one of the ideas that this kind of builds up later on in the future is if I go in and I'm collecting all of these samples, so say they're rating the cafeteria food, I'm taking the average of what they think. I get a sample 1, and then I do it again, and I do it again, and I do it again. I get one that's really low, I get one that's really high, and I get a lot that are kind of in the middle. All of this centers around that true population mean. So the idea of taking these samples, multiple of them, eventually over time, it's going to build out that normal curve that we've already talked about. And that normal curve is always going to center around the true value. So yes, you can have sampling error because you are going to have differences. But eventually, over time, you should be able to tell where the true center is. Now, one way that you can fix this, just in general, of if you think that your samples are way off and they're not representative, but you're doing everything right, is you can go in and you can increase your sample size. So this little prompt is talking about collecting colored balls from a bag and trying to find the true proportion. Usually doing a small sample is not going to work because you're going to get a ton of variability. So you want to get a sample that is representative but isn't going in the direction of a census and collecting data from every single person. So sampling error is good. Non-sampling error is bad. This one isn't as hit as much as the cluster and stratified and the non-response and the voluntary response, but these are the 2 differences between those. Okay, I'm going to go ahead and open your math lab. You do have a math lab for today. The next time I see you, we will go into how to actually write these responses out.